It's a perfect Tuesday afternoon. Roughly 72 degrees Fahrenheit. Birds are singing. People are complaining about traffic. Everything is normal. But strictly speaking, you are basking in the light of a ghost. Because the sun actually disappeared 8 minutes and 19 seconds ago. And that is the speed of light limit. The universal speed of causality. For 8 minutes, we were living in a ghost solar system, orbiting a star that was already gone. And now, the bill comes due. Welcome to the first hour of the rest of your life, which, I'm sorry to report, is going to be significantly shorter than you planned. Here is the first thing that happens, and it's not the temperature drop. For a long time, Isaac Newton thought gravity was instantaneous. He thought if the sun vanished, Earth would immediately notice and fly off into space. But Einstein came along and ruined the party. He proved that gravity, like light, travels at a finite speed, specifically the speed of light. So, at the exact moment the sky goes dark, the Earth stops orbiting. We lose our light and our leash at the same time. We are no longer a planet. We are a rogue spaceship traveling at 67,000 miles per hour in a straight line, heading directly toward absolutely nothing. So, if you feel a little unsteady, that's why. We just left the neighborhood. Hollywood would have you believe that the second the sun goes out, you'd instantly freeze solid, like a cartoon character. But that's not how thermodynamics works. The Earth is essentially a mass of rock wrapped in a very thick blanket, our atmosphere. Think of your house. If your furnace breaks in the middle of the winter, the house does not instantly drop to zero. It holds the heat. It leaks slowly. The Earth has billions of years of stored heat in the oceans and the rocks. So, in that first hour, you won't freeze. In fact, if you're inside, you might not even need a sweater yet. The panic, however, that will be immediate. So, an interesting detail, the solar system would not be completely dark. Not yet. The moon would vanish instantly, of course, because it's just a mirror reflecting sunlight that no longer exists. But look at Jupiter. Look at Saturn. They are still glowing. They're hundreds of millions of miles further away. The light from the sun takes over 40 minutes to reach Jupiter, and over an hour to reach Saturn. So, for quite a while after Earth goes dark, you could look up and see the gas giants still shining, reflecting the light of a ghost star. They haven't received the memo yet. It's a haunting reminder that looking into space is just looking back in time. And then there's the lonely witness Voyager 1. It's currently about 15 billion miles away. To Voyager, the sun is already just a very bright star in the distance. Because of that distance, Voyager won't know the sun has gone out for nearly 24 hours. The darkness has to catch up to it. For almost a full day, it will continue sending data back to a planet that is truly alone in the dark. There is something profoundly sad about a robot doing its job for a master that no longer exists. Back on Earth, the laws of physics are tightening their grip. Within the first week, the average global temperature drops below 0 degrees Fahrenheit. Photosynthesis stops immediately. The plants don't die right away, they go into a sort of dormant shock, but the food chain, that collapses fast. The real problem isn't the cold outside, it's the power grid. Obviously, solar panels become expensive roof decorations instantly, that's a given. But consider wind energy. Wind is generated by the sun heating the Earth's surface unevenly. No sun means the atmosphere stabilizes. The winds die down. Their turbines stop turning. So, we turn to fossil fuels? Good luck. Standard diesel fuel begins to gel. It turns into a waxy sludge at around 15 degrees Fahrenheit. Unless you have winterized fuel stored up, the trucks stop running. The generators clog. Coal piles freeze into solid, unmovable blocks. Our entire infrastructure is designed for a world with a heat source. Without it, our technology isn't just dark, it is broken. And then there is the psychological toll. We are biological clocks. We need the sunrise to reset our circadian rhythms. Without it, sleep patterns drift. Hormones like cortisol and melatonin go haywire. Seasonal affective disorder would become a global, permanent condition. We wouldn't just be cold and hungry. We would be confused, tired, and chemically depressed. By the end of the first year, oceans begin to freeze over. However, ice is actually a fantastic insulator. So while the surface is a frozen wasteland, the deep water underneath remains liquid for hundreds of thousands of years. If you're a microbe living near a hydrothermal vent at the bottom of the Pacific, you probably wouldn't even notice the sun was gone. You don't care about the sun. You run on Earth power. For humans, though, our options are limited. We either move to Iceland to tap into geothermal energy, or we build colonies deep underwater, which honestly sounds like a terrible way to live, but it beats the surface. Because on the surface, it eventually gets cold enough that the atmosphere itself gives up. The air itself eventually freezes. It would literally snow oxygen and nitrogen. You wouldn't just be holding your breath. The air you breathe would be lying on the ground as snow. Okay, take a breath. This was clearly all a hypothetical scenario, a thought experiment. Because in reality, stars just don't hit delete. Physics does not allow for mass to just vanish. So, how will the sun actually end? Well, if you were worried about freezing to death, I have good news for you. You won't. Our planet's immediate future is actually a heat problem. Over the next billion years, the sun will steadily increase in luminosity. It will get brighter, hotter, and expand slightly. Long before the sun turns into a red giant, this sustained increase in heat will be enough to boil the Earth's oceans entirely into vapor, which will render the planet uninhabitable. The oceans won't freeze. They'll boil off into space. In about 5 billion years, the sun will run out of hydrogen fuel. When that happens, it won't fade away. It'll get angry. It will expand into a red giant. It will grow to over 200 times its current size. It will swallow Mercury, it will swallow Venus, and it will likely swallow the already scorched remains of the Earth. And then, the mountains will melt. So, the choice isn't between darkness and light, it's between freezer and incinerator. Which brings us back to today. We live in a Goldilocks zone. We are balanced on a knife edge between the frozen void of deep space and the nuclear inferno of our host star. The sun is a main sequence star. It's middle-aged, it's stable, it's responsible, it pays its taxes. It's not going anywhere for a very, very long time. So, the next time you feel the heat on your face, don't take it for granted. That big ball of plasma is the only thing stopping us from being a frozen rock drifting aimlessly through the dark. It's doing a lot of heavy lifting. If you knew the sun was going to vanish in exactly 1 hour, what would you do with your last 60 minutes of sunlight? Panic? Call your mom? Finally eat that expensive piece of cheese in the fridge? Let me know in the comments. And if you find this content interesting, please hit like or subscribe. It helps me more than you think it might. Thank you for watching. Be kind to each other and take care.